Have you ever looked at this black box, this brick that comes with your laptop, and wondered what's actually going on inside? It feels heavy, it gets warm, but what magic is happening in there to power your device? Well, today we're cracking one open, metaphorically of course, to reveal the secrets of your laptop charger. It's a journey from your wall outlet to your computer, and trust me, it's more fascinating than you think. First, we need to understand a fundamental challenge. The electricity from your wall and the electricity your laptop needs are completely different languages. Your wall socket provides alternating current, or a C. The electricity literally alternates its direction back and forth 50 or 60 times a second. This is great for transmitting power over long distances. A victory for Nikola Tesla in the historic war of the currents against Thomas Edison. However, your laptop, like most modern electronics, runs on direct current, or DC, where the electricity flows in one steady, straight line. So, the primary job of this brick is to be a translator, converting that wild AC from the wall into the calm, stable DC your laptop's battery can understand and store. So how does it do it? Let's follow the path of electricity. The first stop after the power enters the brick is a component called a bridge rectifier. Imagine a clever system of one-way gates. The rectifier's job is to take the alternating current, which is swinging both positive and negative, and flip all the negative swings into positive ones. Now, instead of alternating, we have a bumpy, pulsating DC current. It's all flowing in the same direction, but it's far from the smooth power your laptop needs. It's like a really bumpy road, and we need to smooth it out. That's where the next hero component comes in, the capacitor. A large input capacitor acts like a small, temporary reservoir. As the pulsating DC comes in, the capacitor charges up on the peaks and then releases that energy during the dips. This process significantly smooths out those bumps, turning that rough, pulsating current into a much more stable, high-voltage DC. It's like adding suspension to our electrical car, making the ride much smoother. But now we have another problem. This DC voltage is way too high for your laptop. We need to reduce it safely. This is the job of the most complex part of the charger, the switch mode power supply, or SMPs, and its transformer. Instead of just burning off the extra energy as heat, which would be incredibly inefficient, the SMPs is a genius solution. It uses a tiny switch that turns the high-voltage DC on and off thousands, sometimes hundreds of thousands, of times per second. This rapidly switching current is then fed into a small, high-frequency transformer. The transformer's job is to step down the voltage to the exact level your laptop needs, usually somewhere around 19 volts, because it's operating at such a high frequency. The transformer can be incredibly small and efficient compared to the giant, heavy transformers you'd find in old electronics. But with all this high voltage and high frequency switching, safety is paramount. You absolutely do not want the high voltage from the wall outlet to ever find its way to your laptop or, even worse, to you. That's where a tiny, crucial component called an optocoupler comes in. Think of it as a highly secure bodyguard. It uses a beam of light to transmit information across a physical gap inside the charger. The low voltage side can tell the high voltage side if it needs more or less power, all without a direct electrical connection. This isolation is what keeps you and your expensive laptop safe from dangerous power surges. Finally, after the voltage is stepped down, it goes through another set of rectifiers and capacitors for a final smoothing and filtering pass, ensuring the power delivered to your laptop is perfectly clean and stable DC. So, have you noticed how chargers have been getting smaller and smaller over the years? That's largely thanks to advancements in this switch mode technology and the use of new materials like gallium nitride, or GaN, which allow for even higher switching speeds and greater efficiency, meaning less heat and smaller components. The next time you plug in your laptop, take a moment to appreciate this little black box. It's not just a brick. It's a sophisticated, multi-stage power plant in miniature. It's a testament to incredible engineering, performing a complex electrical conversion dance millions of times a second, all to keep you powered up and productive. It's one of the most essential and underrated pieces of tech we use every single day. Thanks so much for watching. If you found this interesting, hit that like button and subscribe for more deep dives into the technology that surrounds us. See you in the next one.